Assalamu alaikum. Sorry for the delay in joining in. All right, okay. Today we'll be talking about only 16 people are here. So okay, right. Today we'll be talking about the instruction set architecture. So it is an important lecture as well, and your exam will be to the end of this lecture. So your exam on the 17th will be to the end of this lecture, so from lecture 1 to the end of this lecture. Right, okay. So in the past few weeks, we'll be talking about instruction cycles, but with different contexts and different examples and different methodologies. So the namings is very important. Okay, so in the exam, we will make it clear for you. So if I ask you in the exam, if I ask you a question, I'll make it clear what I want from you, and then you have to answer me according to the question. Okay, so make sure you understand every title and what's underneath the title. Right, now last lecture we mentioned the memory and the registers. Do you remember? We had our, I always forget my pen. We had our memory, if you remember, and also we had the registers, if you remember. One of the registers called the IR. Now, I just want to refresh your memory. Do you remember what IR was? Do you remember what IR was? Do you remember what IR was? Yes, instruction registry. And what did it do? What was the job of the IR? What did it do? Yeah, store data for a short time. So yeah, good. I hope you remember. So yeah, it stores data for a very short time. Okay, before they get passed to the decoder. Do you remember in the figure we had the decoder here? Okay, decoder. So it is stored. It communicated with the memory. Okay, this is our memory. Okay, it communicated with the memory and then stored data for a very short while before it passed them to the decoder. Now, the IR, where does it reside? Where's the location of the IR? Or the registry in general, the registry. Where's the location of the registry? Where is the location of the registry in the computer? Inside the CPU, yes, inside the CPU. Right, okay. So because this is inside the CPU, what does it tell us? And look at something. It's communicating with the memory. Okay, it is communicating with the memory, right? So what does that tell us? It tells us, just like the human brain, okay? Imagine this is a human brain, right? Imagine this is a human brain. Oh, well, this is a nice drawing. I didn't expect it to be like this. Right, imagine this is a human brain. You get different location of the human brain does certain actions for you. For example, now you see, now you look and you can see. Now, do you think the whole brain is working on your vision? Of course not. Because if your whole brain was working on the vision, you will not be able to do anything else but just looking, right? So the brain, although the brain is responsible as a whole, but the brain is divided into sections that each section does certain actions for us. For example, I think if we have the eyes here, the vision is at the back of the brain. Okay, here's the area or the sensors for the vision, right? While other things are done different. Like I think the memory resides there. المخيخي that أخذناه في الأحياء. I think it's it's here. Even if you lie, even the lying has its own location. The lie comes here. Okay, so if you do lie, then this part of your brain works, and this is stated in the Quran anyway. So if you do lie, this area of the brain, the forehead, okay, is responsible for the lying. So your brain it is divided into sections that each section does certain action for you. Similarly with the CPU. Now the CPU doesn't do everything like at once and the whole CPU works for everything. No, the CPU is also divided into little sections to help out. Now imagine, for example, a university. Now the university, there's a head, there's what do you call it? The president of the university or the manager of the university, but he doesn't do everything himself because it is impossible. So it allocates or dedicate jobs for other people, other faculty members or other employees to do the job. So so the job will be completed as a whole, right? But no one can do the job just like even our action, even our heart, even the heart doesn't do the job at once. The heart is divided into 4 compartments, 4 rooms, and every room is responsible for something. Okay, so this is the way of organization. We organize our life by dedicating certain jobs to certain parts. Right. So similarly with the CPU, we have the registries. Now the registry, as some of you said to me, it stores data for little or short time. Now why? Because it is communicating with the memory, asking the memory for data. We saw last time how the data is fetched from the memory. It's quite a long process, as we saw. Now, the CPU, instead of the CPU that does this itself as a whole CPU, the CPU is a very busy device. The CPU is a very busy device. It does everything. As the moment you start your machine until the switch off, the CPU is responsible for an enormous amount of information instructions. Okay, so it can't do everything itself. So it dedicated little jobs to different areas. So you have the registries, one areas of the CPU is responsible to communicate with the memory. So we saw the whole process and the long process with the memory. Eventually, the CPU gets the data ready and passes it on for processing. Do you understand the picture now? Okay, so I hope you do. Right. So today we'll talk about something called this operation I just talked about. It's called instruction set architecture. Instruction set architecture, or ISA, also referred to as ISA. Right. Now ISA determines instruction formats, the way the instructions are moved. Okay. One of the types, we have 4 types of ISA. There are 4 types, very important types. Definitely one of them or 2 of them will come in the exam. Definitely, I will explain them shortly. One of them is actually the Little Man computing. Little Man computing is a one-address architecture, right? We talked about the Little Man computing. So anyway, we'll continue. I'll present to you the 4 parts. Right. Now, do you remember the Little Man computing? Why is it called one address? Why is it called one address? Because you have the instruction on one hand, and you have the mail address on the other hand. So you have the instruction on one hand, and you have the mail address, the actual address on the other hand. So you only have one address, which is why we call it a one-address architecture machine. Okay, right. Now, the 4 types of the ISA are, we have 0-address machine, 1-address machine, 2-address machine, and a 3-address machine. Now we will only be talking about the memory. Now we'll talk about the memory, and then I will explain where the registry comes in this equation. What's the job of the registry? Okay, and why the registry is important. Right. So let's take each part separately. Now, if I give you this example, in the exam, for example, this is a little bit messed up. It's covered the equation, right? Okay. Let me just try the equation up here because it's covered. I'll write the equation. Yeah, I'll write the equation up here so we can see. So the equation, if I give you an equation in the exam, and this is funny enough for those who take CS with me, we already in this week's lecture we talked about it was yesterday. We talked about the equation and the precedence rules. and they came up with us again in the IT 110. I didn't plan this. It just happened that it's the same week. In both subjects we took the same material, which is good. So we understand better. Right. So if we have, I'll write this equation down so you can see it. If I give you an equation in the exam, okay, so it's this equation is A times B plus C minus D times E. Now there should be brackets in here, but I think they are missed out. If you want to write them down, I think the brackets were something like that. Okay, we talked about the brackets. Okay, just for those who do not take CS with me and they don't know what I'm talking about, just in case. Right, in any mathematical equation we have something called the precedence rules. It means الأولويات يعني ما نجي نحل المعادلة مثل ما احنا نحب. لا, we have to follow something called the precedence rules. الأولويات دائما times multiplication with division. Okay, multiplication with division, طبعا هاي عامل division, they are of the same family. Okay, and the plus will minus, they are of the other family. Always the multiplication and the division are stronger than the addition and subtraction. They are always stronger. So if you see them in an equation, we have to do them first. I do not mean that the multiplication is stronger than the division, and also I do not mean that the addition is stronger than the subtraction. I said they are of the same family. So if you see a subtraction comes on the left before the addition, you do the subtraction first. Okay, unless you have brackets. If you have brackets, you need to solve what's inside the brackets first, then you go back and finish the equation. And if you have a bracket inside the brackets, you need to solve the innermost bracket. For example, in this example here, we need to solve this first and then go to the outer brackets. Okay, that's theoretically. But also, if you want to solve, in this example, if you want to solve this first, then this, it is fine. Because think about it, it will not change the answer. Whether you work with this part first and get this part, or vice versa, it will not make any difference. It will be the same. Now, in assembly language, we will work from the left, so we will handle this first. Okay, then we will do the bracket because it will not change. But we will still follow the precedence. We will still follow the precedence. Let me get rid of something here. Okay, right. So I put in the equation up here because when I do this now, it will cover the equation. We want to see the equation. So oh, come on. Right. Okay. I forgot something. Right. So it's A equals A times B plus C, if I remember correctly, minus. I think it's like this. Minus C. This is actually 9 because it's gonna. Okay, never mind. Minus C times E. Okay, and I said the brackets were here and the brackets were here. Okay, obviously if I do now this, because obviously I'm gonna have to move this arrow, but I'm gonna have to do without it. So so we need to see the equation so we know what we're doing. Okay. Right. So if I give you, always remember something. In the zero address machine, it deals with binary operations, which means either the memory reference either 1 or 0. If we have value, it'll indicate the number 1, which means that we do have value. If we do not have value, it'll give us the 0, which means there is no value. I will explain this more. Also in the zero address machine, we have terminologies called push and pop. Now push indicates we have load. We need to load or input, and pop is for output. Okay, pop. show me the results. Right. So if we take this, if we have this equation, now look at the instructions, how they are done. Now this is only for the zero decimal machine. So in the exam, which is why I said to you, it's very important that you know the titles, because in the exam I might ask you, for example, I say like, solve this equation, for example, using the zero address machine. Now, don't ask in the exam. Your teacher will not, or the examiner, or the al-muraqib, the supervisor, will not answer your question if you say what is the zero address machine, or how to do this, or remind me, because we will not remind you. You need to remember this yourself, right? So we come and say, okay, then we have the first value A. So we need, obviously, we said push is like load. So we need to push A. Okay. Now A is a variable which has a value. So the memory reference will say, okay, then we'll give it a binary that indicates 1, which means there is a data. Okay, so the processor has to go and get it. Right. Similarly, we have B. So we're pushing A, we're pushing B, that's a data. Then we're doing the multiplication. So we have A and we have B. Now we need to multiply them. Now the multiplication has no value itself. So the symbol multiplication has no value. So it is 0 on the memory reference, because itself has no value. It's only an operation. Now we finished this part. Okay. Now we need to go to the next part. So we have 3 variables inside this big bracket. We have C, D, E. So if you have the big bracket, you need to state all the variables. So we need to push C, D, E. Okay? Because they are inside the big bracket, we need to state all the variables. Then we need to do multiplication and subtraction. Straight away, the program will see. This is what I mean by we have procedures. We have these brackets, as we said, we work because they are innermost brackets. We need to work with them first. So the computer will say, okay, then we have a multiplication. What it will multiply? It will multiply these 2 numbers, these 2 variables, the D and the E. Okay. Once we get a result, but not something, it has no value for the multiplication itself. When we get the result, we need to subtract. Okay, subtract what? Subtract the answer from C. Okay, also subtraction has no value. Then, after we've done that, we need to do addition. Okay, because we got an answer for this. Now we need to do addition. Okay, and addition itself has no value. Once we've done the addition, then we got the whole the answer. So now we need to pop A, which means that we need to get the answer. This A is equivalent to this A, while this A is equivalent to this A, because this is like a value that we need to load, but this is a destination value that we need to find. So we say pop A. Okay, right. Is what I will do in this lecture. I'll go a little bit different. Every type I give you, I'm gonna ask you if you understand. Okay, so now, because I want to make sure that we have 4 parts. Every part that I give you, I want you to understand it. So now, if you have any question, please ask me now. Raise your hand now. If you have any question regarding the zero address machine, ask me. There's one question from Munira. Yes. No. Yes, go on.
Yeah, hello, Doctor. But
Hi.
I would like to ask you about, depending to what you in the second operation, you put multiplication, then subtract, then addition. Depending to what?
What do you sorry? Yeah, I put multiplication and
the second operation, which is multiplications. Yeah, depending to what you organize the operation in this way. Because Ms. Afrah, she told to us that the first letters in any operation in zero address machine, you have to make it in one group, and the rest will be the other group. So Is that right? Because I understand from you different
definitely.
than I understand from Ms. Afrah.
No, that's right. The first letter always is a group.
Yani always.
Yeah, which is C, inside the brackets. Okay? So, look, inside the bigger brackets, how many variables do we have? We have 3 variables. Okay? So, we need to say that the 3 variables. So, this is 1, and these 2 are linked together because they are contained in an inner bracket. Right? So now, when we say multiplication, what we mean is, obviously, these are grouped now because they are in these little brackets. Okay? So we need to multiply them 2 together first, and then subtract from the 3rd variable that is in the big group, if you know what I mean. Did that answer your question? Did that answer your question? Okay, so what else? Here. Yeah.
Yeah, but my question, yani, I will clear it more. You push C, then D, then E, okay? But then after that, you multiply D, then subtract and addition. How the multiplication will be D with E? How the computer
because you
understand
put
that?
the brackets, didn't you? Because you put the brackets.
My question clear or not that much?
I think so. Your question is how then the computer understands that we are multiplying D with E. Is that right? I think this is what you meant. How the computer does understand that it multiplies D with E. Okay? Because you already put them in a bracket. And if you remember from Java, we did say, as soon as you put a bracket, the computer will deal, obviously the computer will deal with the precedence, right? So when you put CDE, and then you put multiplication, subtraction, addition, the computer will know the order, depending on the equation that you have. Because you put the brackets, the computer knows the sequence that goes through, it solves the innermost bracket first, then comes out to the outer number, which is C, then does the addition with the rest. Was that clear? Okay? Right? Questions? Another question? Okay. So we'll move on. Again, if you think of any question, I will also leave some time at the end of the lecture for you to ask me. Right? Okay. Now let's continue. These are all linked to the same thing what I just talked about. See, so when you do hang on. When you read a question, here you go. Now when you do the multiplication, the D and E were already in a bracket, as you can see here. Okay, they're already in a bracket. So once you do the multiplication, there's only one possibility here, which is the one inside the bracket. Okay, so it does them as a sequence. Okay, right. So all these are right. Okay. Okay, that's fine. Now let's move to that's what I wanted to know in the zero address machine. Okay, you know the sequence, how it goes. Obviously, in the exam, I'll give you a different equation, and then you're gonna have to solve or to give you the instruction, and I'll make it clear for you. Right. Now we have another type, which is the one address machine. As I said, it's exactly as the little man computing, more or less. You have the code on one side, and you have the address, the mailbox address, on the other side. Now, if we have the same equation, okay, but imagine these times, the brackets have been, I didn't create the size myself, but I think the brackets have been forgotten here. Just a second, just let me remember. I think, just a second. Yep, here we go. Yeah, I think the brackets were something like that. Okay, okay, yep, right. So, in the one address machine is very similar to the little man computing. So it goes with almost the same operation. Now, if we have this equation, but the brackets are differently located at the moment, so you say, okay, then obviously we do not have push and pop only in the case of zero address. Here we have a load and store and output, right? So we load A, but here load should be written like this, load, LAD. So in the exam, I want to see it in this form. Right? Okay, this is just no problem. This is just like for the sake of showing you the structure. Right. Now, obviously, we need to load A. We know this, right? If there's a user input, you need to put in input. But imagine that we have these variables are already defined in the program, so you just need to load the data. So load A. Now, here it's a little bit different. Here we do not have a binary. Now, when you say load A, how many times the CPU will enter the memory? If you have this memory, okay, and this is the CPU. How many times the CPU does need to access the memory? Need to access the memory once to get the value of A. Right. Then we multiply the A with B. How many times we access the memory now? Again, only once to get the value of B. Then we add the C to it, right? Again, we need to access one time the memory to get the value of C. Now we finish this bracket. Before we move to the next, we need to store the data that came out of this bracket. Let's call it, for example, T1. For example, call it T1. So we store the data, as you remember in the calculator in the LMC, when some of you asked me what if we have 3 numbers to add, okay? So I said to you, you add the 2 numbers, you store the data, and you add the third. Separate operation. Similarly here, you finish inside the bracket, done, then you store what comes out, and then you continue. Right. Now when you store the variable and call it T1, how many times you can access the memory? Again, you can access it one time, because it's just like you're going to go inside the memory and store the T1. Right. Then after that, we load D, okay, as we did before, and then we multiply by E, we access 1. Then, we have a new value here. Let's call it T2, right? And we store it. Okay, so we have 2 numbers stored. Okay, 2 values stored. Now, after this is done, we need to load the value of T1, we need to load it, okay? And then we subtract T2 from it, right? So we store T2, but it is still, we have it. You don't have to store it if you don't want to. You don't have to store it, but in this instruction it stores the T2. Then we load T1 and straight we subtract T1 or T2 from T1. Okay, subtraction. So now we completed the equation and we have the value A. So then we have value for A and we store it or we output it. It's up to you. We can store it. You can have an output. Never mind. So and then we store the data, the A. And note something as well. Also you need to remember with the assembly, with the instructions, we need to the variables are always written in capital, even if they are given in small in the equation. You need to write them in capital. This is fairly simple. Also, the one address machine is fairly simple. Is this understood? If someone else has a question regarding the one address machine, please ask. If you have a question regarding the one address machine, ask. Okay, you understand it. It's fairly simple. Right. So let's move on to the third type, which is, okay, I forgot to tell you something. Now, the total number of accessing the memory, you can, obviously it's a silly question, you can tell, you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times, it says here, we have 10 times we access the memory. Okay? The reason we put in this, because we will compare with the registry, if we have a registry. Okay? But directly, it is 10 times we need to access the memory. Right, let's continue. Now the third type is the two address machine. Fairly interesting, fairly simple as well. Now on the left hand side, always on the left hand side we have the code. Then, this is quite different. We have two addresses. It's called two address machine. We have two addresses. The one in the middle, address 1, is source and destination at the same time. So you use it as a source, but at the same time you store onto it. You use it and you store onto it. And the address 2 is always source. Address 2 is always a source. Right. So let's take the example. Oh, sorry. Cancel this. Oh, I don't. It's a page. What have I done here? Right. Is it viewed? I think I messed up something. Yeah, the slides are gone. Oh, you go. Right. Okay. I don't know what happened there. Right. Sorry. Okay. Always technology causes problems. All right. Okay. We did this. Okay. Now we're talking about the two address machine. Okay. So with the two address machine. I'll say to you, the one in the middle is the source and destination, and the one on the right-hand side, the second address, is always a source. So let's take the example, right? So if we have the same equation, imagine the brackets are here, okay? Now look how the operation is done, quite different, which is why, again, I said to you, you need to remember the names. Now, always, with the two address machine, always we begin with an instruction called move, which means moving a value and give it another name. Right. So we move this little a, we move it to a variable we call t. I will tell you in a minute why we do this. It's quite good because we're saving instructions. Okay. So we save it. As I said to you, the one in the middle. So this is the instruction. This is in the middle. It is a source and destination. Okay, so now we use it a source as a variable, and now the one on the right hand side is always a source, and we want to have we move in a to t1. So we created t1 as a source, and then we store in a inside a. We store in a inside t1. Why? Now, in the previous example, when we did the instruction and then we stored in a variable called t1. Okay, we did it, right? But now this is simpler. Why? You have a box, and you're collecting data in it. Imagine this before this, right? Okay. Imagine you move in a house. What you do, you get all your stuff in one area, then you start putting in the box. Okay, this is a longer process. Imagine you take everything from the shelves, from the house, you put them in one area, and then you start putting in the box. Okay, it is doable, but it takes time. What if you bring a big box and you straight take stuff and put in the box? Eventually the box will have the same material, but the second method is easier. Because you're doing it as you go along. Similarly, same thing with the storing thing. And instead of doing all the arithmetic, then we store inside a variable. Okay. Now we are storing inside the variable as we go along, as we can see now. So first of all, we move the value a inside the variable. We call it t1, for example. Then the second thing we need to multiply. What do we multiply now? Obviously, we multiply t1. Okay, we multiply t1 because t1 has the value of a. T1 has the value of a. We multiply t1 by b. Right. In the first step, always the move has two access to the memory. How? How? You need to get the value of A and store it inside T1. So you get the value of A, you store it inside T1. So this is two memory access. Now, in the second level, which is the multiplication, okay, you need to get the value of T1, then the value of B, then store the output, the natij, store the result inside T1. So we have a three memory access. So you bring T1, which has the value of A, multiplies it by B, but always, the middle one is source and destination. So it is a destination now we need to bring back to it. So the result of the multiplication between T1 and B has to be stored back inside T1. Right. The third one, we need to add C. So now T1 has the value of the multiplication between A and B. Okay? So this value, we add it to C. And then the result, again, we store it inside T1. So again, we have three memory access. Three memory access. Now, we finished with this. Straight away, we do not need to bring an instruction called store as we did before, because we are storing as we go along. So now we have a complete value of T1. Now we have the complete value of T1. Now we move to the second part. Again, we'll do the same idea. We create a function called move. So we move D inside T1. Same thing. We need to multiply T1, which has the value of D. We multiply it by E. So we have three memory access. Right? Now we have a value of T2 ready because it will store inside. Now straight away we just need to subtract T1 and T2. Just subtract. Right. Now when we subtract them, where is the result stored? It has to be stored in T1 because this is the way it works. Okay? So when we subtract T1 and T2 from T1, the result has to be stored in T1. If it was the opposite, if I say to you, for example, sub T2 T1, then obviously you subtract T1 from T2, but the result has to be stored in T2. Always the middle one is used for source and destination at the same time. Now we finished eventually. Eventually, we are not interested. We got the value of T1, but we are not interested. We have no T1 inside the equation. We are not interested in T1. We are interested in A. So we need to move back. We need to move the value of T1 inside. My pen stopped working. Inside the A. So now we have the value of A. Simple enough, I think. Now, okay. But look what we've done. Instead of having 10 steps, here we had 10 steps. Instead of having 10 steps, okay, we had only 1, 2, 3, 4, 5, 6, 7 steps. But we have the number of accessing the memory is quite large. The number of accessing the memory is quite large. We have to work them out. So how many times did you tell me? How many times did you access the memory now? 18 times. Yes, thank you. 18 times because it's just like we have to add them up. So 2 plus 3 plus 3 plus 2 plus 3 plus 3 plus 3 plus 2 gives us 18. So 18 times we access the memory. It does say here. Now, 18 times, quite a large number. What if we cut it down? We can cut it down by here's the registry comes. So 18 in the previous method, 18 times we had to access the memory. But if we had the registry, the number will be reduced much. Why? Now instead of having the T2 or T1, we have in the values of the registry. So what happens is the calculations we did previously. The registry is not interested what happens here. It's not interested. It's interested in getting the final value straight away. Oops. Okay. So the R is straight away got the value. So it only need to access the memory once. Okay? The memory did all the work, and now the registry did it communicated 18 times with the memory, but now it will pass the CPU only one time. Okay, so it will pass the CPU this result and this result and this result and this result and this result. There is no result here. Okay, just a subtraction. It will not give a result because the result is stored in here already. By the way, this is not a T2. It's a mistake. It is an auto. Just correct it in your slides. This is not a T2. It is an auto. It's just a mistake. I cannot correct it on my end because this is an image. It's not like a text file which I can write on. It's an image. Okay? But you need to correct it. So it's not a T2. It's an auto. Right. So here we don't need to get the result because the result of this is actually the final result which we can pass to the CPU through here. We can just give it the value of A. So it's only one time we communicated from the registry to the CPU. So 1, 2, 3, 4, 5, 6 times. So we reduced from 18 to 6. Now if I ask you in the exam, I might ask you in the exam, obviously first if I ask you this question in the exam, but I might ask you two kind of questions in the exam regarding the registry. First of all, I'm going to have to ask you to work it normal in the memory as we did before. But then I might ask you, say, okay, then repeat your work using the registry or continue your work using the registry. If I do that, then you're going to have to present something like this for me. Okay, or I might ask you a simple question and say to you, what is the advantage of using the registry? If I ask this, you only need to answer me this: cut memory references down, or reduce the memory references, or whatever you want. You need to say to me that it actually reduces or cuts off the memory reference down. Okay, this is understood. Do you have a question regarding the dual address machine? If you do, please ask. If you do, please raise your hand. You don't? Are you sure? Hang on, something's wrong here. Are you with me? Do you hear me? I want to make sure that you are still here. Okay. You are with me? You are with me. So you do understand then. Okay, I'm quite happy then. Right, let's move to the last. We move to the last one, which is the 3 address registry. Okay, we're approaching the, okay. Right, we'll go through this now. Right, oops. Okay, now the 3 address registry, which is the last one, again, it's fairly simple. Now we have the code on the left-hand side as usual, but this time we have a destination as one separate address. Not like the 2 address, the 2 address machine, we had the one in the middle as a source and destination at the same time. Here is different. We have a slot. We have a slot is prepared only ready to accept results. Okay, so it's only a destination, and we have 2 addresses for sources. So we have source 1 and source 2. Let's give the example. Okay, same thing. Okay, let's work this out. So now multiply. By the way, don't write it like this, please. Write it as mul. Okay. Again, the slides not always shows the exact thing. Never mind. Okay, it's okay. So, but in the exam, write it like mul. Okay, as multiplication. Right. So we'll do the A, B, and C multiply A and B. Okay. So now we have a separate slot for the destination. Then we have these 2 numbers that we multiply, so source 1 and source 2. We multiply them and we put the result inside T1. Now, we need to add T1, which now this is T1. Okay, we need to add, stops working. We need to add T1 to C. Okay, and store the result again in a slot called T1. We might overwrite it. Oh, by the way, when we are doing T1, what's happening? It's just simply overwriting. So if this is T1, let's say this is address 9, for example, and this is T1. Okay, it's just overwriting it. just every time overwrite. As I said to you, always in one slot we can have only one value, so it overrides it, or you can open another slot. It doesn't matter. You can either open another slot if you have an empty space, or you can overwrite. Overwriting is better, obviously, because here you save memory location, and the process will be a little bit faster. Okay, so we have three steps. We get in value of fetching A, fetching B, and storing to T1. Next one, we fetching T1, adding C, and then back storing to T1. So we have another three steps. Okay, again, we need to multiply. We have T2 now. We multiply D and E and store it inside T2. Then we need to sub T2 and T1 and straight away store it inside A. Very simple. But instead of saying load A and stuff like that, or store A, it's easy. As soon as you do sub, you're already storing in A. Very simple. So we cut down the instruction to 4 only, and this time we have 12 instructions. Now, okay, if we had the registry, it will be, if we have the registry, it will be 6 times. Okay, 2 for this, because it is it's got the result of them and has the storage. Okay, so it's given 2. Here we already have R1. We only need C. Okay, so this is 1. Here we need D and E, so we have 2. And here we only need A, the value of A, so we have 1. So it cuts down to the half this time, from 12 to 6 memory addresses. Now the last slide. Okay, comparison is quite important actually. What I will do, comparison I will explain it in a separate lecture, because I want to give you practicing questions. By the way, I will ask for this question now. One of you can answer me. Do you have extra lecture? I think you have extra face-to-face lectures. Okay, one of you now, the first one, gets the microphone and answer me this question. I think, oh no, never mind. I think if you don't know, okay, I think you will have an extra, just before the exam, you will have an extra face-to-face lecture. And in this lecture, what we will do, I will pass to the other lecturers, to the other my colleagues. I will pass them a list of maybe practicing questions that you can do. Okay, so this is quite important actually. I want to explain it separate, and I will give you practicing questions as well, because it's quite important, right? Any question regarding the 3 address machine? Any question regarding the 3 address machine? Or any question? Do you have any question regarding today's lecture? Any question? Do you understand? Are you sure? Okay, I'm surprised and I'm very happy. Okay, we have one question. Right. Yeah, go on.
Hello, Doctor. I would like to ask you just how can we cut memory addresses down?
Yeah, using the register, obviously. Use the register. So, for example, here in the normal memory, sorry, it's quite messy now. In the normal memory, for example, we have 3 times we need to access the memory, right? If we imagine the CPU wants to access the memory, which is the registry, accessing the memory, it accesses 3 times. For example, in the first line, we need the value of A, so this is 1 time. We need the value of B, this is 2 times. And then we need to store to T1, this is 3 times. Now, the opposite side, if we communicate with the registry only, so the registry already communicated with T1, so now it needs to pass the information to the CPU, right? It needs to communicate to the CPU. Now it's already got the inside if there is a slot for storing. I said it works as a very temporary storage, so it will only need to communicate A and B, okay, with the CPU, with the memory. It only needs to communicate A and B, but the value is stored inside the registry, which is already inside the CPU. It's already inside the CPU. So only twice we need to access the memory, because it is now stored in the registry. Simple. The registry itself is inside the CPU. Okay, so the CPU is less load on the CPU now. Okay? We have a question from who's now Munira? Yeah.
Yeah, Doctor. Sorry, but I didn't understand the second address machine. Not the registry, the previous way, the first way, without registry. I didn't understand that. Could you explain?
This one.
Yeah, this one.
This one. Right. Let me delete this mess. Just let me clear it a little bit. Oops. I think this is okay. This is fine. It's watchable. Right, yeah. So I'll repeat these steps in a short. Right. So in the to address, we always start with something called move. It's a move instruction. Now, in the move, as I said, again, I give the example that, for example, in the Windows machine, if you're moving a house, you get all your stuff in one place, then you put them in a box. Now, this will take time. What if you bring the big box and straight away, instead of taking your stuff into a location, then store them in the box, no, straight away, take the stuff that you want to store and put them in the box as you go along. As you go along, put the stuff in the box. Now, the same idea applies here. So if we get a storage location called, if we get storage location called T1, now what I do, I move the value of A to T1, right? Then I multiply it with with B. Sorry, first of all, so I get the A, right? Store it inside T1. Now, then I need to do the second part, which is the multiplication. Second step, multiplication. Now T1 has the value of A, because we moved value A to T1. So it has the value. So I can straight multiply T1 with B, but according to the to address machine rule, always the one in the middle slot is a source and destination. So when you do your operation, it will store inside the middle one, because this is the rule. This is the rule of it. You store inside the middle. So we multiply T1, which is A originally, by B, and the result will be stored in T1. We continue. So now when we do the addition, T1 has the value of the multiplication between A and B, so it has the result. So if we add the result to C, okay, we add the result to C, the result, the new result, will again be stored inside T1 according to the rule. Okay, so now the good thing is we do not need to create an instruction called store, because the value is already stored as we go along. As I said, you bring the box and you put things in it. It's storing, so you have no problem with it. You do not need to create a function or an instruction called store. Right. So you finish the first part. The second part, you do the same. So you move the value of D to a new box called T2. You multiply with E. Okay. The result is stored in T2. Now straight away you have the two boxes ready for you. They are there with you. You subtract the T2 box from T1. Okay. Then the result will be stored in T1. So this is the final result. What you do now, but because again we don't have T1 in the equation, we have A. We are interested in this A. So straight away say, okay, then move T1 inside A. So now we have the final answer. Is this clear enough?
Yeah, it's clear. Okay, about the memory access.
Yeah.
In the first one we get 2 and third.
So, why? Why? Because we have A and we store it to T1. So we need to fetch the value of A and we need to store to T1. So we have 1, 2. Okay? While in the second instruction we have a 3. Why? We need to get the value of B. We need to get the value of T1, and we need to store the new result in T1. Is understood?
Yeah, okay. Thank you, Victor.
Right?
Yeah,
Another question? Okay, no problem. Another question? Another question? Okay, so no question. So yeah, again, so the exam will be until the end of this lecture, and please do revise. Make sure you understand everything. The recordings are there for you. The slides are there in the folder, all there for you as well to read. You can there's the book as well. There's the internet. So even any topic you don't understand within the slides, go and search the internet. Go and, for example, look at the tool address machine. For example, if you just send something, go. There are like so many examples on the web. Go read the book as well. So look, where is the tool address machine, and read on it. Okay, it is important to read and to understand in order to get a good grade in your midterm. The midterm worth 25% of your total grade. So it's quite a lot of marks. Okay, so please make sure you try to get a good grade out of that. If you do not understand anything as well, you have your face-to-face lecturer. You can ask them, and also refer back to me as a last choice as well. You know, try to go through all the process just to get the load off me. But if you're really stuck and you do not understand anything, then you can email me with your question. Okay. So this is the end of today's lecture, and I hope you got some benefit out of it. Until I inshallah see you next time. So have a nice weekend, and fi amanillah.